the time and the trouble to be part of this lesson this morning. And we are carrying on with our topic of transformation, which we began yesterday. You will recall that yesterday I spoke about transformation, and of course I defined transformation in relation to reflection as well as rotation and enlargement. The first one was translation, and after translation we went to reflection, and then rotation as well as enlargement. And of course we defined translation as a movement of any object, be it a cell phone that you have on the table. If you move it from one point to the other, we define that movement mathematically as a translation. And I've given you some examples of translation in relation to some of the geometric figures, such as a triangle. You'll recall that yesterday I also gave you triangle ABC, which you had to translate. And of course, triangle DEF as well, which also needed to be translated. And this morning, I'm going to talk about the line of symmetry, which goes hand in glove with a reflection. And of course, at the end of the lesson, I will just talk about the homework that I gave you, which consisted of about 3 questions. And you'll recall the 3 questions. The first 2 questions were translation, and of course, the other one was rotation. Remember, rotation about 90 degrees in a clockwise direction. And this is something that I've taught you yesterday. And today we are going to learn about the axis of symmetry. Now, what do we mean when we talk of the axis of symmetry? Who can tell me maybe what comes to mind? And I appreciate if you can just use the mic this morning. When we talk about symmetry, is it for the first time that you hear the word symmetry? If not, can you please recall what you have learned up to so far about symmetry in the previous grade, in grade 6? Do you come across the word symmetry for the first time? If yes, you are also welcome to just try to tell us what is your understanding of the word symmetry, or what do you think is symmetry? What do you think is the axis of symmetry is when we talk about the axis of symmetry? If you want to try, you are welcome to do so. Now, without any doubt, I'm just going to define our word here, which is the key word, which is symmetry. And we define symmetry as follows. We say that a shape has a line of reflectional symmetry when you can draw a line on the shape so that one half of the shape forms the mirror image of the other half. So we say that a line of reflectional symmetry exists when you can draw such a line on the shape so that one half of the shape forms the mirror image of the other half. I'm sure we are not talking about the mirror image for the first time this morning. In fact, this week. We have spoken about the mirror image. If you remember yesterday's lesson, which was based on a transformation, where we defined 4 concepts of a transformation. Amongst others, we spoke about reflection. We defined transformation, and amongst others, we spoke about reflection. And what did we say reflection was? If anyone can recall, what did you say about reflection? We said that a reflection simply means a mirror image. A mirror image simply means a reflection. And I gave you several examples, if you can recall. Do you remember the mountain next to the lake? Do you remember the tree next to the river, which was reflected on the river itself? There was a reflection of the tree, which was facing upside down on the, reflected on the river, next to the river. But of course, we also had a hand, which was reflected. So a reflection simply means a mirror image. So this morning, I'm teaching you now about the line of symmetry. And we say that the line of symmetry simply means that you can just draw a line on the shape. The line must be on the shape so that one half of the shape can form the mirror image of the other half. And I'm going to show you some of the examples. But what is important to note this morning is that a shape can have more than one line of symmetry. It's not every shape, but some shapes can have more than one line of symmetry. This simply means, as we have just defined here, you can draw more lines of reflectional symmetry on a shape. I'm talking about those shapes where you find that there are more lines of symmetry. In this case, of course, we are carrying on to demonstrate, excuse me, that a shape can have more than one line of symmetry. So please note that you don't only find one line of symmetry in all the shapes. Some shapes can have more than one line of symmetry, meaning that you can actually cut the shape, or you can draw a line in such a way that one half of the shape is the mirror image of the other half. So in other words, we are now back to reflection. So it means that the other half of the shape can be reflected on, can reflect the one half. All right, we are carrying on. So we are going to take a look at some of the examples of symmetry. That is what we are going to do this morning. We are going to have a look at some of the examples of symmetry. And the first one is as follows. You can see the letter A. There's a line that is drawn, a black line there on the blue letter A. That line that is drawn on the letter, it cuts the letter A into 2 parts, or rather into 2 halves. And as you can tell, the one half which is on the left-hand side of the line is a mirror image of the other half, which is now on the right-hand side. And this is what we mean when we talk about symmetry. We are defining symmetry the line of symmetry as a line that can divide any geometric figure in such a way that one half of the geometric figure is a reflection of the other half. Now, let us go to the next shape. You can see that we have got the next shape here, which looks like a parallelogram. It looks like a trapezium. If you remember the word trapezium, which is one of the four-sided figures. And you can tell the difference now. Look at the trapezium. How did we draw the line of symmetry? You don't just draw the line. You don't just cut your geometric figure into two. You have to make sure that when you draw such a line, the one half will be a mirror image of the other half. So you can see that the line that has been drawn is a horizontal line. Because if you draw a vertical line, you will not have the one half, which is a reflection of the other. And the same goes for the letter A. You can see that we have drawn a vertical line. Had we drawn a horizontal line, that would defeat the purpose of reflection. It would not realize our objective of reflection. Because in reflection, as I've said, one half must be the mirror image of the other half. And of course, you need to learn to identify and draw the lines of symmetry in any geometric figure. But at the same time, I want you to recognize, but also to describe the reflection that you see. Especially on a squared paper, it will be easier when you have a squared paper, because when you draw any geometric figure, you can actually tell by the number of squares on the left-hand side, as well as the number of squares on the right-hand side of your reflection line, or your line of symmetry, as it is known. All right, so those are the two examples of symmetry. I've given you the first two now, and of course, we are talking about a line that can be able to cut your shape in such a way that the two halves reflect each other. The two halves have to definitely reflect each other. And we have defined this as the line of symmetry. So never forget, excuse me, don't forget that I also indicated to you this morning that some of the geometric figures can have more than one line of symmetry. But if you look at the first two here, these two, each one of those has only one line of symmetry. So these two figures do not have more than one line of symmetry. So it's only one line each, and we have just demonstrated to you. Now, let's go to another example. I have a square here, and of course you can see a square, a triangle, a rhombus, a circle, a pentagon, and an octagon. So these are geometric figures. There are about 6 of those. And each one of those, I've decided to draw a line of symmetry. Now, the line of symmetry, as I've said, must be drawn in such a way that if you fold your geometric figure there, the one half will fit exactly on top of the other half. Just like when you read a book, if you open your book, the center of your book in the middle page, the two sides, or that line that divides the two sides, is a line of symmetry. Because when you fold your book, when you are done reading and you fold it back, the one side or the left-hand side will fit exactly on top of the right-hand side. And that is what we mean about the line of symmetry. So you can tell now with the square. We have the square here, which looks exactly the same. That when you fold your square, you can tell that one half will fit exactly onto the other half. So in other words, if that is the ground for sports, what is called the center there, the center of the ground, if you draw a line there, that line is the line of symmetry. That is why when soccer matches are played, the soccer ball is put right in the center. That center there, there's a line, that line that divides the ground into two. Those are two equal parts, and that too is a line of symmetry. And you can also do it in a triangle. But of course, it also depends on the type of triangle. If you look at this triangle, it's more like an equilateral triangle. It's more like an equilateral triangle where all the sides are equal. So you can draw the line of symmetry also on the equilateral triangle. But of course, you can also draw the line of symmetry on an isosceles triangle, where the two sides are equal. You can also draw the line of symmetry. In other words, you can divide your triangle in such a way that one half will fit exactly on top of the other half. And the third one, of course, is a rhombus. We are talking here about a rhombus. And of course, you can also subdivide your rhombus in such a way that the one half will fit exactly onto the other half. The other one, which is not on the picture, is a kite. A kite. I'm sure you all know a kite. A kite as well, you can actually draw a line of symmetry in such a way that the one half is equal to the other half. The same goes for the circle. As you can see, we've drawn the line of symmetry in the circle. We've also drawn the line of symmetry in the pentagon. And of course, the octagon as well. Remember that an octagon is an 8-sided figure. The pentagon is a 5-sided figure, but this pentagon here, you can see that the two lines are equal at the top there of the pentagon, where it forms almost a roof. Right, of course you can draw the line of symmetry even at that level. I'm now going to move directly into other examples of symmetry. Now we are proceeding. I've said to you when I started this lesson that certain geometric figures can have more than one line of symmetry. That is what I said. I said that when I started. And now we have got a six-sided figure here, also known as the hexagon. And as you can see, we have more than one line of symmetry. That is what we have. You can actually draw more than one line of symmetry in this particular figure. As you can tell, that the other side, if you look at if you take any line of symmetry in this case, you will tell that the one side is a reflection of the other when you cross the line. And of course, the other side, or the one half, can fit exactly onto the other half. And of course, we call this the line of symmetry. So I've given you about several examples now where I've shown you only one line of symmetry. And of course, I've given you now an example which consists of more than one line of symmetry. Now, we say that a shape has a line of symmetry if you can fold it. If you can fold it so that the one half match exactly the other half. And that is how we also expand our definition. We say that a shape has a line of symmetry if you can fold it in such a way that the one half match exactly the other half. So you should be able to fold it like the book. When you fold it and put it back in the drawer, the one half will be able to match exactly the other half. And that is what we mean about this. That is what we mean about the line of symmetry. A shape has a line of symmetry if you can fold it so that the one half match exactly the other half. And this is what we mean when we talk and expand on the line of symmetry. I'm going to give you an example. If you look at this arrow here, the arrow can be folded in such a way that the one half will match the other half. And you can see in the arrow there that I've actually shown you how to draw the line of symmetry. I'm talking about the green arrow there, and I hope that everyone can see that. We say that this line of symmetry is drawn in such a way that, as I've defined previously, this shape has a line of symmetry in such a way that you can fold it so that one half will match exactly the other half. And of course, if you look at this green arrow there, if you were to cut it out of the page and cut the line of symmetry, you can actually take the two and they will match and fit exactly on top of each other. And that is what we mean when we talk about the line of symmetry, where you can cut the one half and put it on top and match exactly the other half. We've also said that a shape can have more than one line. And we have given you the example. A shape can have more than one line of symmetry, meaning that a shape can be divided into a wide range of halves, like this shape here, the hexagon. You can subdivide your shape into two in many ways or in different ways. All right, so that is what we can do. So this hexagon here can be subdivided in 12 different ways. So there are 12 different lines of symmetry in this particular picture. If you select any line and cut your hexagon into two, you will see that one half will be able to fit exactly on top of the other half. And that is what we mean when we talk about the line of symmetry. I hope that the lesson on symmetry makes sense, and I'm going to now give you an opportunity to do the following activity. I want you to find the line of symmetry in the following figures. And I'm going to give you about 3 or 4 of those. Here's the first figure there. I want you to draw this line. I hope that this figure, by the way, I hope that you have a pen and a paper with you. I want you to draw this line, and thereafter, as I've said previously, find the line or lines of symmetry. So if there are more than one, you can find. If there's only one, please also indicate and tell me how many lines of symmetry do you get there. Let's draw the line of symmetry. I hope that you have a pen and a paper. You can use a pencil, preferably, in your scribbler there, just to draw this shape, and thereafter identify the line of symmetry. And tell me, talk to me about that line. How many lines do you have, for instance? That is the first shape. I hope that you have seen the shape. And thereafter, I will take you to the next shape. And this is the next shape. I also want you to draw a line of symmetry. If there's more than one, please, you're welcome to do so. Right. Can we find a way now to draw the shape in such a way that we have got the line of symmetry? Can we draw this shape in such a way that we have the line of symmetry there? And of course, the next one will be the shape here. I'm just giving you the one. I hope that you are done with the first two. Can we now draw the third one? Just draw the shape and make sure that you tell me how many lines of symmetry are there. So basically, I've given you 3 diagrams up to so far. Can we proceed with the first one? Right, I've looked at the first example, and of course, this is the last one. This is the fourth one. If you can just also draw this particular geometric figure and tell me how many lines of symmetry do you get there? And of course, we can take it from there and answer the first one. I hope that you are now drawing the last one. I've given you enough time to do so. And of course, let's carry on now. Right, can we carry on now? Can we carry on? And of course, we will come back to activity 2. Yes, Kumbo, your hand is up. Theopatra, please go ahead. I'm sure you are going to answer the first one now. Please go ahead, unmute. Let me unmute you quickly. Let me just. Right, Theopatra, please go ahead. Your hand was up. Please go ahead. You can just talk to me how many lines of symmetry did you find in the first diagram? How many lines of symmetry did you find in the first diagram?
Sir?
Yes, Theo?
I found 1 line of symmetry on that shape.
Great. So you found only 1 line of symmetry. I fully agree with you. This shape consists of only 1 line of symmetry. And I'm glad that it's a pity you can't show it to me, but I'm glad that you found only 1 line of symmetry. Thank you very much indeed, Theo. Let's go now to the next hand and looking at the next picture now. let's look at the bigger picture now. How many lines of symmetry are here? Is there anyone who is willing to answer this one? In this activity one, how many lines, or is there a line of symmetry? Maybe we should start there. Okay, I forgot to, let me go back to the chat. I know that some of you are already, on the chat group. I deactivated the chat for the simple reason I wanted you to be able to see the picture clearly there. Right, I see Theo has already answered the first one saying 1. Angelina also says 1. Amu also says 1 line of symmetry. Great. I'm glad that you have answered that. I also see 1 line of symmetry. Right, can we proceed to the next one now? Let's go to the next figure there. In the third one now. Now we are in the third geometric figure. How many lines of symmetry do you get? I'm sure that you've been able to draw this. I know some of you can just do it by inspection. Just by looking at the picture, you can already tell the number of lines of symmetry which you can get in such a way that when you take 1/2 of the picture, it will be a mirror image of the other. So I have a picture in front of you now. Just tell me how many lines of symmetry can you draw in this picture? Right, Amu Komote says you can get 2 lines of symmetry supported by Huapili. Angelina says 1 line. Right, I want us to talk about this figure, yes. Amu Komote says 2 lines. Huapili and Lihumo also say 2 lines of symmetry. And then Angelina says only 1. Angelina can see 1. Theopatra and Gumbo can see 2 lines of symmetry. Right. I want us to reflect. I'm not going to agree with you because you are the majority, but I'm agreeing with you because that's exactly the correct answer. I mean, Amu Komote, Huapele, and Theopatra, you are correct. When I look at the picture, you can actually draw a vertical line just in the center of the arrow. The top arrow there, as well as the bottom arrow, you can draw a line that can divide your geometric figure into 2 equal parts. In other words, if you take 1/2 and put it together with to realize the importance of symmetry there. And of course, we say that this is a mirror image. So the mirror image is formed when you draw a line in such a way that the 2 sides will be equal. One can fit exactly on top of the other. And of course, if you look at your figure there, your geometric figure, Angelina, if you go and draw a horizontal line right in the center of the picture, if you go into the center of the picture, maybe the first might be to measure your geometric figure in terms of its length, and then you go right in the center of the length, and then you draw a horizontal line. Or you go into both sides. You see, this thing looks like the The black picture there looks like a rectangle. So one side obviously is equal to the other. So once you have measured your length, or the length of your rectangle there, you can basically go to the center of one of the lengths and the center of the other length, and then you join them together to form a horizontal line. And this horizontal line will divide your geometric figure into two equal parts. I hope that it makes sense. I hope that it does. Right, the last one. Let's go to the last one. How many lines of symmetry are there in this figure? How many lines? Bipilo N says one line. Theo also says one line. Amo Komote also says one line of symmetry. I fully agree with you as well. You can draw a vertical line of symmetry in this picture to divide your picture into two equal parts, which can form, one can be the mirror image of the other. So that is the last one there. Now, in the last activity, which I think you will also be able to do, you need to accurately redraw the following figures on a squared paper, and thereafter find all the lines of symmetry. I'm just going to show you, when you look at this reflection here, this should be done on a Cartesian plane. So I want you to draw something like this on a Cartesian plane, where you are able to tell that where the y-axis becomes your line of symmetry. That is what I want to do. And of course, if you look at this, we can tell that rotational symmetry, you look at how a shape can be turned and still look exactly the same. So the order of rotational symmetry counts how many times this happens. So you have got about 6, in fact 7 different figures there, which I want you to draw on a Cartesian plane. So meaning that if you look at the first figure there, the yellow one, you need to draw it on the Cartesian plane. In other words, your y-axis and the x-axis should both be, in actual fact, the y-axis must be the line of symmetry. That's what I'm interested in. So you draw that arrow on a Cartesian plane where the y-axis is the only line of symmetry. So you are going to divide your arrow into two right on the y-axis. And I hope that this will bring us to the end of our lesson this morning. Once again, this lesson is brought to you by the STEM Digital School in partnership with the Sasol Foundation. Until we meet again tomorrow, on Monday, sorry. Thank you very much indeed. Have a nice weekend.